Okay, 3.4, we're going to deal with properties of logarithms today, which are all on your formula sheet, and we went over them in the notes, so let's just practice them now. I'm starting off with a really hard problem here, but the first one, you want to set these equal to something, because we need to change these in the exponential form where a log is an exponent, so we need to know what we're calling an exponent. I'm going to use y in this case because I don't want to use x. The x is being used right here. But clearly this equals some quantity, we'll call that y. It equals some number. All right, now we'll change it in exponential form, so we'll do base to the exponent equals the argument. Now once again, a log is an exponent is the important thing to remember. So that way you know that a log is an exponent. So when you see a log expression, or a log equation in this case, the exponent is always what's right here. All right, and obviously the base is here. So you can do base to the exponent equals what's left over, which is the argument. All right, that's something we need to get down right away. So basically I have this, what my log expression equals is negative 9x minus 5. That's my answer, negative 9x minus 5, because that's what y is, and that's what our log is. Okay, we can't simplify it anymore. All right, next. Once again, actually this is an exponential form, so let's change it into log form. To do that, we do log base 11 of, actually let's set this equal to something again. So we'll do log base 11 up here, negative 2 plus 8q. Set that equal to something. I'll use x this time. X isn't being used. So we do log base 11 of x equals log base 11 of negative 2 plus 8q. Once again, when you're writing a log equation, a log is an exponent, so here's the exponent. That has to come from the exponent. Now we can see that our answer is just negative 2 plus 8q, because that's what x is, which is our whole expression that we started with. Okay, the next one's a beast. You might not like this one, but once again, let's do the same thing where we have log base, this big number, 0.04 to the k equals some number, I'll call it y. Now changing the exponential form, so we do base to the exponent equals the argument. Okay. Now from here I'm kind of stuck because I don't recognize how these numbers relate in any way. But if I can somehow get the same base on both sides, then I can compare. Use the one-to-one property again that we've been using. So 0.04, what is that? Well, that's really 4 over 100, which we can simplify to 1 over 25. But 1 over 25 is really 1 over 5 squared, or I'll make it 5 to the negative 2 raised to the k, which is really 5 to the negative 2k. So this whole thing simplifies to 5 to the negative 2k. That's a key right there, because I might be able to get this as base 5. So basically, what power do I raise 5 to get this big number right here? What I started doing is, I guess you could just solve this equation separately now. That'd probably be the easiest way, where you're solving this equation. So log base 5 of 390,625. So do that in your calculator, and that gives you 8. So what that means is this right here is really 5 to the 8th power, right? This number is really 5 to the 8th. So I'm going to change this to 5 to the 8th raised to the y. And I don't need these parentheses. I'll just make it this. Now I've basically rearranged these to have the same base, so I can compare 8y has to equal negative 2k. Now let's divide both sides by 8, and that gives us y is equal to negative k over 4. So that goes here. All right, last one, same thing. Set 6 to the 9 log base 6 of 8 minus 8 log base 6 of 9 equal to something like x. Okay, change it into log form, so it would be log base 6 of x has to equal the exponent, which is 9 log base 6 of 8 minus 8 log base 6 of 9. Okay, now I'm going to do some log properties that are on your formula sheet to simplify the right-hand side to get it to look like the left-hand side, so I'm going to combine these logs. So I'm going to bring the exponents up for both of them. That's one of our log properties. So the log base 6 of 8 to the 9th minus log base 6 of 9 to the 8th. And then the difference of two logs is really log of a quotient, so I'll make it log base 6 of 8 to the 9th divided by 9 to the 8th. And that still equals the log base 6 of x. I can then compare that this has to equal this. So my answer is 8 to the 9th divided by 9 to the 8th, which goes right here. And make sure you use the right parentheses when you enter that in so that it accepts it. Okay, more practice with log properties. So the log of a quotient is really the difference of two logs. So I'm going to make this log x to the 18th, y to the 18th minus log of z to the 12th. And then log of a product is really the sum of two logs. So I'll make this log of 18 plus log of y to the 18 minus log of z to the 12th. That property is on our formula sheet. Now I'll just bring the exponents down. So I'll just write this as 18 log of x plus 18 log of y minus 12, or how about plus 12, or plus negative 12 log of z. That way I can see what they want for A, which is 18 in this case, B would be 18, and C would be negative 12. Okay, another problem like the first one. I have 2 log base 2 of 3 equals something like x. Change it into log form where we do log base 2 of x equals log of 2 to the third. Now we can just compare. It equals x equals 3. So this whole thing just equals 3. You can enter that into your calculator even. Okay. Next one, same thing. Let's do 10 to the log of 2. Let's call it equal to something like x. Let's change it into log form. So it'll be log base 10 of x equals log of 2. So then x equals 2 is our answer here. And the last one, e to the natural log of 7. Well, I can, these cancel always, and if you're not sure why, call it equal to something like x, and change it into log form. In the log form, this would be natural log base e of x equals natural log of 7, which x just equals 7 then. So either way, you can say these cancel, and you just get 7. All right, same thing with this next problem here. First one is e to the 5th times the natural log of 5 right there. I'm going to set that equal to something like x. Change it into log form, so it'll be natural log base e of x equals 5 natural log of 5. I'll bring this 5 up to the 5th power right there, so it's really 5 to the 5th right here. You might want to enter that as a number, I'm not sure, but 5 to the 5th. Next problem, 10 to the 3 log base 10 of 5 equals something like x. Change it into log form, so it'll be log base 10 of x equals, I'll write the base 10 since that has base 10, 3 log base 10 of 5. So log is an exponent. Then I'll bring the 3 up from that spot right there, and x equals 5 to the 3rd, which is 125. Next problem, same thing. Log base 3 of 27 to the 6. Call it equal to something like x. You have 3 to the x equals 27 to the 6th power. This time, I need to get the same base, a little easier than the first problem we did. I'm going to make this 3 to the 3rd raised to the 6th. So really, this is 3 to the x equals 3 to the 18th. So you multiply, so x equals 18 here. Okay, next problem, I want to simplify these to get an exact value. So we have the sum of two logs, which is really, if they have the same base, we can make that the log of a product. So 15 over 4 times 40,000 divided by 15. These 15s cancel, and I have 40,000 divided by 4, which would be 10,000, so it'll be the log of 10,000. And that's our exact value. We could actually simplify this some more. You can do this in your calculator if you want, or call it equal to x and make it 10 to the x equals 10,000. So then this is 4 then. X would be 4, which is exactly what your calculator will give you. Next one, same thing. Use log properties to simplify this. So first of all, the sum of two logs, if they have the same base, you can make them the log of the product. So I'll make that log base 5 of 15 times 405. And then I'll bring this 5 up right here. Get rid of it from there. And then when you're subtracting, you can make that a quotient. So now I'll make that the quotient divided by 3 to the 5th. If you have like base right there. So then I can simplify this number in my calculator and make this log base 5 of 25, which we can also do in our calculator, or we can just do 5 to the x equals 25, which we know is really 5 to the x equals 5 squared, so x equals 2.